In this video, we're going to go over something called synthetic division of polynomials. Synthetic division is a shortcut, okay, that can be used when you are dividing polynomials, but there are rules, okay? We have 3 rules, okay? Rule number 1, it can only be used if the divisor is linear. So if your divisor is not linear, meaning degree 1, okay, if your divisor is not of degree 1, you cannot use synthetic division, okay? Rule number 2, your divisor must be of the form x minus a. So what does this mean? This means the coefficient on x must be 1. Okay, and rule number 3, you must use placeholders. So this is a shortcut, so I just have to show you the shortcut. And then you just have to make sure you follow the process of synthetic division. So we will divide using synthetic division. So number 1, x squared plus 2x minus 24 divided by x plus 6. Now we did this problem in the previous video when we did long division of polynomials, okay? But I'm going to show you how you would do the same problem but using synthetic division. But first thing, we have to make sure we follow our rules. So we have to make sure that the divisor is linear. Is this linear? Yes, we just have x to the first. Divisor must be of the form x minus a. Yes, it is of the form x minus a. A here is just -6. We really need to make sure the coefficient on x is 1. Do we need any placeholders? So you need to make sure you must be in standard form, okay? You must be in standard form. Do you need any placeholders? Okay, we can add that in. Must be in standard form. Okay, if you want to consider that the third one, part of the third one, or make it the fourth one. Okay, so now what you do is you figure out what makes this 0. Okay, so what makes x plus 6 0? That's -6. Okay, that's actually the value of a. So what you do is you put -6 on the side in a box. Now, after you've put this in standard form and you've put all placeholders in, you put all of the coefficients of all of these terms, you list them here. So that's going to be 1, that's going to be +2, that's going to be -24. Now you put another line down here, and you put a little line right here. Now, the reason this is a shortcut is because if I'm taking x and I'm dividing it, I'm taking x and seeing how many times it goes into x squared, okay? That means whatever the coefficient is on this term, okay, it's going to be the coefficient of my quotient, and I'm always just going to be 1 less than the degree here. So if this is x squared, if I divide it by x, I'm just going to get 1x, okay? If this wasn't here and it was just 2x minus 24 divided by x plus 6, if I'm taking 2x and dividing it by x, I'm just going to be left with +2, okay? So what you do is you bring the first coefficient down. So you bring this first number down, 1. Then you take this number and you multiply it by the number in the box, 1 times -6, and you write it right below the next coefficient. Now what we do is we add up the column. Now this, what we're doing here, okay, adding, this is the opposite of what was this term here. Remember, when we had our first, when we went like this in long division and we had our first term here, we took this, we multiplied it by this, and we subtracted it. That's basically what's going on right here. But we can do it without any of these variables, only when x has just x to the first, 1x to the first. So 2 plus -6, that gives me -4. -4, now we repeat, -4 times -6, and you put that number right here. And now we add it up. -24 plus 24 is 0. Now, these represent the coefficients of the quotient. Okay? Now, this would be the remainder. So that means this, now you work to the left. So after, to the left of the remainder, this would be the constant term, and this would be x to the first. So our quotient would be x to the first minus 4, no remainder. Or 1x minus 4. So in synthetic division, you're just actually dropping the variables and you're doing all of the operations that you would have just done in long division. That's what's happening in synthetic division. Okay, so we'll practice more. All right, number 2. Negative 5x to the third plus 7x squared plus 2x divided by x minus 4. Okay, so what we have to do is we have to check. We can't even do synthetic division if the divisor is not linear. Is the divisor linear? Yes. Good. So now we check, does it have a coefficient of 1 on the divisor of x? Yes, so that's good. So now we check. Do we need any placeholders? Okay, we're in standard form, but it's missing the constant term. So you need to put in the placeholder. Okay, so now we're ready to set up our synthetic division. So we say to ourselves, what makes this 0? 4. So that's what goes in the box, 4. So now we list our coefficients of the dividend. Negative 5, 7, 2, 0. I always put a little space here because this would be the remainder. Okay? You always bring the first one down. That is because if I am taking this and dividing, okay, I'm taking negative 5x to the third, and I'm going to divide it by x first, I'm always going to just be left with negative 5 as my coefficient. So now you take that first number, you bring it down, negative 5 times 4. You get the product and you put it here, and then you add up the column. 7 plus negative 20 is negative 13. So now you take negative 13 and you multiply it by the number right here. Negative 13 by this number would give me negative 52. And so now we add up the column. 2 plus negative 52 gives me negative 50. Negative 50 times 4 gives me negative 200. Add up the column, that gives me negative 200. This would be the remainder, this would be the constant, this would be x, this would be x squared. So our quotient is negative 5x squared minus 13x minus 50 plus negative 200 over, that's the remainder, you put it over the divisor, x minus 4. In number 3, we have 2x to the fourth minus 5x squared minus 3 divided by 2x plus 3. So we have two things we have to be concerned with to begin with. Number 1, we can only use synthetic division if the divisor is linear. Is the divisor linear? Yes. So can we use synthetic division? Yes, we can. Now, because it's linear, we can use synthetic division, but we can't start the process of synthetic division until x has a coefficient of 1. Does x have the coefficient of 1? No. So to make it have a coefficient of 1, we would have to divide that by 2. So we would have to divide that term by 2. But if this entire expression was to maintain its value, we cannot just divide the divisor by 2. Okay? We would have to divide the dividend by 2 as well. But there's something you could do. You can either divide the dividend by 2 now, or just divide your quotient by 2 at the end. Okay, you could just divide your quotient by 2 at the end. So that's what we'll do. That way we don't have to work with fractions here, okay, with inside your dividend. Now before we start this process, so what we really have here is x plus 3 over 2. And we're going to work with this dividend, but at the end, we're going to take our quotient and we're going to divide it by 2. That would have been the same as if we divided this by 2 and didn't do anything with our quotient at the end, okay, which you could do if you want. But let's look at our dividend. Does it need any placeholders? Yes, it does. It needs 2 placeholders. Okay, Okay, so what makes x plus 3 halves equal 0? That's going to be negative 3 halves, which would be the same as if you just said 2x plus 3 equal to 0. Okay, so we've got negative 3 halves. Okay, now we put 2, 0, negative 5, 0, negative 3. Okay, we bring down the first, so that's a 2. 2 times negative 3 halves, that's just going to be negative 3. And now we add up. 0 plus negative 3 gives us negative 3. Negative 3 times negative 3 halves, that's going to give us 9 halves. So we have to add this up. So we're going to want to rewrite negative 5, that's negative 10 halves. So negative 10 halves plus 9 halves gives me negative 1 half. Negative 1 half times negative 3 halves gives me positive 3/4. So we're going to want to do 0 plus 3/4. That gives us 3/4. 3/4 times negative 3 halves would give us negative 9/8. We want to add up the column. That's going to give us negative 24/8 plus negative 9/8. That's negative 33/8. Now we have to take every term and divide it by 2. Dividing by 2 is the same as saying we're going to multiply by 1/2. So 2 times 1/2 would just be 1. Negative 3 times 1/2 would be negative 3 halves. Negative 1/2 times a half, that's negative 1/4. 3/4 times a half, that's 3/8. Negative 33/8 times 1/2, that's going to be negative 33 over 16. Okay, so this would be over the remainder. Right now our remainder is x plus 3 halves. So this is negative 33/16 over x plus 3 halves. This would be the constant. This would be to the first, to the second, to the third. So this is x to the third minus 3 halves x squared minus 1/4 x plus 3/8 plus negative 33/16 over x plus 3 halves. Now, this term right here, this is called a complex fraction, your remainder. I don't like this, okay? Right now, this is your remainder. And the issue with this is that you should not have a fraction within a fraction. So if you notice, I have 3 halves in the denominator, okay? So that's a problem. So, and I have negative 33 over 16 as part of it as well. So the first thing I could do is, okay, I could just, what could I multiply negative 33 over 16 by so that I wouldn't have a denominator anymore? That would be by 16. Now if I just multiply the denominator, this part of this, so here's the fraction. If I just multiply this by 16, I have to multiply this by 16. Okay, that's going to give me negative 33 over 16 times x, that's going to give me 16. 3 halves times 16 over 1, that's going to give me plus 24. 16x plus 24. So this gives me x to the third minus 3 halves x squared minus 1/4 x plus 3/8 plus negative 33 over 16x plus 24. Okay, you don't want to have a complex fraction. A complex fraction is a fraction within a fraction. We have 2 things happening here. We have 3 halves and we have negative 33 over 16. So the lucky winner number here would be 16 because 16 over 16 isn't going to change the value of this fraction, but it's going to clear both from having your complex fraction anymore. Okay, so here's what our quotient would be for problem number 3. So I just want to show you before we finish up this video, I just want to show you different ways that you can see division appearing. So this expression, okay, right here, is probably the most common ways that you can see an expression that is going to tell you that you need to divide. But if you saw this, okay, it means the same thing. It means you have to do division. This is the dividend, this is the divisor. And here's the third way. Whoops. This is another way people like to write it. It looks like it's multiplication, right? But this is the factor that's raised to the negative first power. You're not supposed to have negative exponents in a simplified expression. What do you do with negative exponents? You bring it down. But it's this entire factor that's raised to the negative first. So this would be the same as 2x to the fourth minus 5x squared minus 3 over 2x plus 3, which if you write it out horizontally would be this statement here. So just know that there are a variety of ways that you can write out the expression that still means you are dividing polynomials. So you could just see the division symbol, you could see it as a fraction, or this expression right here is actually division of polynomials.